Welcome to L'Hopital's rule. So this is a bit of a throwback to limits. Um, it's not to do with integration, so this is just sort of supplementary material. So recall that sometimes we had limits where we went to 0/0 or infinity over infinity. So if we had a limit as x went to some number of f of x over g of x, go to either 0/0 or infinity over infinity, that this could actually have lots of different results. This limit could be pretty much anything. And we learned a couple techniques of algebraic manipulation to evaluate, but those techniques don't always work. So on the algebraic manipulation, would not always work. So sometimes we could cancel out, say, a common root, a common factor that would give 0 from the numerator and denominator and get rid of the 0/0 situation. But we didn't always have that option. And so L'Hopital's rule will give us another way to evaluate such limits. So with L'Hopital's rule, essentially what we have is, suppose that we have a limit as x approaches c of f of x over g of x is indeterminate form. So it goes to either a 0/0 or infinity over infinity. Could be plus or minus infinity, doesn't matter. Then what we get is that this limit of x approaches c of f of x over g of x is actually the same thing as the limit as x approaches c of f prime of x over g prime of x, assuming this second limit exists. So if the second limit exists. So we're going to take a look at 3 of those special limits that we learned earlier in the semester, and we'll just use L'Hopital's rule to evaluate them. So let's go ahead and start off with the limit as x approaches 0 of sine x over x. So sine x will definitely go to 0 as x approaches 0. And x will also go to 0. So this is a 0/0 scenario. So let's go ahead and apply L'Hopital's rule. So we're going to say that this limit of x goes to 0 of sine x over x is the same thing as the limit as x goes to 0 of the derivative of sine of x over the derivative of x. I apologize, it's not updating again.